Hello, everybody, and welcome to lesson 7.2 on page 441, which is Introduction to Geometry, Points, Lines, and Planes. Underline the title, please. Alrighty, and today we're learning. The objective is to understand basic terms and postulates of geometry. So basic terms are these three: points, lines, and planes. These are called undefined because there's really no explanation. Undefined terms. There's only three of them in geometry, and those are the building blocks of everything geometry builds upon. And so those three are the first things you're going to learn. And most of the time in this lesson, it's just a matter of knowing how to write geometry and knowing the words. So it's more of a vocabulary exercise and knowing how to write it. So you really are not doing any math, I mean, adding and subtracting. So undefined terms are terms that really have no explanation. And I think later in the lesson, we're going to talk about this again. Postulates are facts in math or in geometry, facts. And postulates don't have to be proven. They are understood to be true. Now, theorems are the ones that you need to prove in math. Any ideas you have that need, most of them need to be proven, but postulates are so simple that they're just believed to be true as facts without proof. Okay, let's read in the middle of the page. Geometry, I'm reading here. Geometry is a mathematical system built on accepted facts, which is those postulates. Postulates, basic terms, which are the three: points, lines, and planes. Those are the three basic terms. And definitions. Okay. In geometry, some words such as point, line, and plane are undefined. Undefined terms are the basic ideas that you can use to build the definitions of all other figures in geometry. Although you cannot define undefined terms, it is important to have a general description of their meaning. So that's what we're doing in this lesson. And here we are. This is important. Please make sure you highlight, underline, and come back to it when you do your homework or prepare for a test or quiz. The description, a point indicates a location and has no size. It's just simply a location. So you can draw a point fat, or you can make a dot. It does not matter. It has no size. It's just a location. How to name it, let's underline that. How to name it, super important in math to name it correctly. And again, this lesson 7.2 is simply on how to name things, okay? You can represent a point by a dot, there it is, and name it by a capital letter. So it's capital. So any letter, A, B, C, but it has to be capital, and that indicates a point. A line is represented by a straight path that extends in two opposite directions without end, important, and has no thickness. A line contains infinite many points. So between any 2 points, you can always squeeze another point between, and between those, that's why you can squeeze infinite many points on a line. The reason you can squeeze more points between 2 points is because points have no size. Yeah, so that's the definition of a line. And how are we naming it? You can name a line by any 2 points on the line. And the symbol is this. So notice you have 2 points, and then you have this line above it with the arrows pointing in both directions. This is how you write a line. So here's your 2 points, line AB. You can also name it backwards, line BA, so the order doesn't matter. Or sometimes you have a lowercase letter. Again, uppercase, lowercase makes a difference. At the end of a line, sometimes you see a lowercase letter and you can name it like that. You can say this is line L. Okay. And last, it's a plane. A plane is like a sheet of paper or the floor you're walking on in your room, okay? It's two-dimensional, and usually a plane, when I draw it, I make it like a little tilted, not straight, and that indicates a plane. A plane is represented by a flat surface that extends without end, again, without end, just because the picture here has borders, it really goes in every direction, infinite. Yeah. And it has no thickness again. A plane contains infinite many lines. So you can draw infinite many lines in this plane, and they're all going to go in the same direction that plane is going. You can name a plane by a capital letter, such as P, plane P, right there, or by at least 3 points in the plane that do not lie on the same line. So here, A, B, C, they cannot lie on the same line. And so you can also name it a plane ABC. So here on this page, you find the most important items you're going to use in this lesson. Study it carefully. And we're moving on to the next page, page 442. And let's see what we have on the top. It's talking about collinear. Collinear means collinear points are such that they lie on the same line. Points that lie on the same line are collinear. If they do not lie on the same line, they are non-collinear. And points and lines that lie in the same plane are coplanar. Yeah, so if they are in the same plane, points, coplanar, or the line, yeah. These are all on the same plane. Like if you have things lying on your floor, those are all coplanar. If you pick one up, let's say you have something on the floor and you pick it up, that's not coplanar anymore. It's now in 3 space. It's 3-dimensional because you took it out of that floor, yeah? All the points of a line are coplanar, that you can put them on the same sheet of paper. All right, those are the most important words, and there are more. And we're naming points, lines, and planes. First of all, why can figures have more than one name? You can name it forward, backwards, like for example, let's do the problem first. What are 2 other ways to name RS? So notice up on top here, this symbol means line. Yeah, so I'm looking for line RS, and there it is. And how else can I name it? I noticed there's another point on this line. I got actually 3 of them. I got R, Q, and S. I could also name it QS by these 2 points. I can name it backwards SQ. I can say RQ. Or I could call it line L. So there's 4 other ways, yeah? Why can a figure have more than one name? Depends which direction you go. Yeah, you can go this way or this way and name it that way. What are two more ways to name plane P? So I'm going to erase this so we have a good view again. So here's the plane P. Usually when they name a plane with an uppercase letter, it's shoved in the corner. Yeah. So this is your sheet of paper. Remember, it doesn't end here. It keeps going in all directions, but you have to make some kind of drawing, so you have to give it borders. Yeah. So what are two more ways? So plane P you can name by 3 non-collinear points. Name it by any 3 non-collinear, they cannot be on the same line, but they has to be on that plane. It can't be off the plane. Can't be picking up from the floor and still use that letter, that item to name your floor. You can name it by any 3 non-collinear points in that plane. So I'm going to use R, V, and S. So I call it R, V, S. What are two more ways? Or QVS, also non-collinear. QVS. Again, you can say it backwards. You can call it SVR. So the order doesn't matter when you call it the plane. What are names of 3 other collinear points? Oh, look at that. I just saw some. Let's look at this other line. T, Q, N. T, Q, N are collinear. They're on the same line. What are the names of 3 other? T, comma, Q, comma, N. So you have to put comma between otherwise you might want to call it plane T, Q, N. Do you notice the difference? I called the plane RVS, no comma, but I used the points and I put a comma in between. So this is an important distinction, how to write it. Okay. Collinear means in the same line. So get used to those words. What are 2 points that are not coplanar or on the same plane? Not coplanar, not on the same plane with points R, S, V. Notice how they have a comma between the points. R, S, V. So I go back to the drawing and I make myself very familiar with what's going on. R, S, V, R, S, V. So that R, S, V describes this sheet of paper, this plane, right? So we're looking for points that are not in this plane. So T is not in the plane and N. Those are not in that sheet of paper. T, comma, N. Okay, so by now you should be kind of familiar with the word collinear, non-collinear, coplanar, no, not coplanar. What is a point? How do we write a point? How do we name a line? And how do we name a plane? Okay, so that's pretty much for that part. Let's go to page 443 on top. Let's read and underline. The terms point, line, and plane are not defined because their definitions would require terms that are also defining. You can, however, use undefined terms to define other terms. A geometric figure is a set of points. Space is the set of all points in 3 dimensions. So that's space. So 3 dimensions would be length, width, and height. So where you can put something inside, yeah, 3 dimensions. Space is a set of all points in 3 dimensions. Similarly, the definitions for segment and ray, so now we're introducing 2 new words, segment and ray, are based on points and lines. That isn't saying much up here, but I thought I'd read it. So we have another defined, these are defined terms. They have definitions. Let's look back on the first page if they said undefined terms. Yep, see, those are the 3 undefined. They don't need much explanation. Those are the basic building blocks of geometry, point, line, and plane. And now we have definitions. Where are we? Up here, yeah, defined terms. So a segment is part of a line that consists of 2 endpoints and all points between. So a segment has 2 endpoints. Look over here at the diagram. It starts at point A and it ends at point B. Remember, a line has no beginning and no end. A line goes on forever in both directions. You cannot measure how long a line is because it keeps going. But a segment you can measure. How long is it? Yeah. So we name a segment by the endpoints. So like for this one would be AB with just a line on top, no arrows. See how it doesn't have those arrows? Yeah, so that would mean segment AB. Okay, a ray is part of a line. So a ray has a beginning right here, but no end in one direction. So it has a starting point, in this case, point A, but then it goes in one direction, infinite, continuously. Okay, so that would be a ray. So you can name a ray by its endpoint, which is point A, and another point on the ray, so which is point B. Notice that it's important how the arrow points. So AB is how we name it, but that arrow on top tells us it's going starting at A and it's going to the right continuously through B. So the ray, it's important to see which way the arrow points, yeah? The order of points indicates the ray's direction. That's super important. Okay, and then last is opposite rays. So an opposite ray are 2 rays that share the same endpoint and form a line. So this would be the endpoint here. So look at it, CA, this is this ray, because it starts at C and goes toward A, and that's how that arrow shows, see? And CB is this one, and it starts at C and it goes in this direction. So C is the common point. Or same endpoint. I should use the same words. So with the rays, you just have to remember that the first letter is your endpoint, and the second one is the direction the ray goes through, goes toward. Okay? Okay, next we are here, problem 2, naming segments and rays. EF and FE form a line. Let's look. EF is this ray, and FE is this ray. So I'm going to go that way. Are they opposite rays? Explain. Well, no, because they have no common endpoint, because one starts at E here and one starts at F here, because they have no common endpoint. How do you know if two rays are opposite rays? They form a line, which they do. These still form a straight line, but they have a common endpoint. And have a common endpoint. Okay. And the next page. Now we're on page 444. So it's talking about postulates, which in the beginning of the lesson, that word came up. It's also called axiom, but I hear postulate more than axiom, is an accepted statement of fact. So we don't have to prove it. No need to prove. Otherwise, we prove everything in math. Okay. Postulates, like undefined terms, are basic building blocks of the logical system in geometry. You will use logical reasoning to prove general concepts in this book. You have used some of the following geometry postulates in algebra. For example, you used postulate 1, which is coming below. When you graphed equations such as y equals 2x plus 8, you graphed 2 points and drew a line through the points. So that's postulate 1. It says that through any 2 points, you can only draw one line. There's no other way to draw a line through these 2 points. Yeah, so the minimum you need to make a line is 2 points. This is what that says. Through any 2 points, there's exactly one line. And that's a postulate because it just makes so much sense and is so easy to grasp that nobody has says, you need to prove that to me. So there you are, through any 2 points, there's exactly one line. There's no other way you can draw this line. Line T, okay, is the only line that passes through both points. Then it's talking about intersection. So when you have 2 or more geometric figures, their intersection is the set of points the figures have in common. Well, when 2 lines intersect, you're only going to have 1 point in common. And I believe that's the next postulate. If 2 distinct or unique lines intersect, then they intersect in exactly 1 point. So that's another postulate that says if these 2 lines keep going in opposite directions forever, they're never going to turn around again and bend and say, oh, I'm just going to intersect one more time. Nope, there's only 1 point where they intersect. Okay, and the third postulate is if 2 planes intersect, like if you take 2 sheets of paper and you mush them through it, you're going to have a line where they intersect. If 2 unique planes intersect, then they intersect in exactly 1 line. Yeah, so here it is, line ST. This is our line, is where the 2 planes intersect. All right, let's look further. Okay, let's not worry about the top. Finding the intersection of 2 planes. So now you have a 3-dimensional figure here, right? And so you see that it has 6 faces, like a dice. So each face is called a plane, yeah, because you can make, it's a flat surface, correct? So 1, 2, 3, 4, 5, and the front is 6. What are the names of 2 planes that intersect line BF? So my first instinct is to go straight and see where line BF is and make it out, and there it is. And it's asking name 2 planes, and so I would say it's this one on the side here and this one. So how do I name these 2? I'll call this front cover. Remember, we are naming planes by a minimum. You have to have 3 points on that plane. I can call it A, E, F. I can call it A, whatever this letter is. I covered it. B, A, B, F. I can also call it A, B, E. Or I can use more than 3 letters. I can call it plane A, B, F, E. I can also do that. It just says you have to have a minimum of 3 letters. You can use more letters, but they all have to be in that plane. So that's how I'm going to name the front. And now I have to also name the side right here. And I'll call it B, C, G, F. So those are the 2 planes that intersect in BF. Why do you only need to find 2 common points to name the intersection of 2 distinct planes? Because in this postulate, it was postulate over here, postulate 3, it says if 2 distinct planes intersect, then they intersect exactly in 1 line. And to name 1 line, we only need 2 points. So I can say postulate 3 tells me that 2 planes intersect in 1 line. And well, we should just make it very, very systematic. Postulate 1 tells me that to name a line, I need 2 points. I need 2 points on that line. Well, that should cover it. Teaches them to ask these questions, right? All right, and I think we're done. Oh, there's an interesting fact on the next page, this tripod on top. You've seen these, right? Sometimes you see them at a photographer, or they use these to measure angles when they build something or dig a ditch. Tripods. And so a 3-legged tripod, if you set it up, you got 3 points that touch the ground. And those 3 points are the minimum you need to define this plane, which is the ground. Okay, let's read it. Photographers use 3-legged tripods to make sure the camera is steady. Okay, you wouldn't be able to steady it on just 2 legs. Think of it. When you have a chair, if you look at these old chairs people used to milk their cows, when they actually sat down to milk in the olden days, they had little wooden like, what do I call it? They're not even chairs, but they had 3-legged little chairs to sit on, because that's really all you need to have your chair not wobble. 3 legs, think about it. If you have more than 3 legs, it won't wobble either, right? If it's balanced right, if they're all the same length. And so a minimum of 3 will make it steady. And that's a tripod. And that's why a minimum of 3 points define a plane. Okay, the feet of the tripod all touch the floor at the same time. You can think of the feet as points and the floor as a plane. Yeah, as long as the feet do not lie in 1 line, yeah, they can't be like that. Otherwise the tripod would tip over. All right? They will lie in exactly 1 plane. Okay, So not in the same line, but off, not collinear. Okay, so there's one more postulate, it looks like. And it says, through any three non-collinear points, not the same line, not on same line, there's exactly one plane. So you need a minimum of 3 points that are not on the same line to define a plane, okay? Plane P, there it is the only plane that contains these 3 points. So you're kind of like taking a slice out of the universe by defining a plane. There's infinite many planes that make up the universe, by the way. You could take infinite many slices out of a 3-dimensional shape. It's kind of interesting. All right, let's look at problem 4. What plane contains points? See how we're listing the points with a comma, so I know they're talking about points. L, M, and N, shade the plane in the figure below. So I first find the points L, M, and N. Well, none of these sides contain these 3 points. These 3 points are not in any of the 6 sides that make this box because of this thing over here. So when you see it, it'll hopefully pop out at you that it's a diagonally slice, kind of like that. And so this would be it's kind of a diagonal slice out of this shoebox. Okay. So this is plane MLN is a diagonal slice. And now we're asked to, what is the name of a line that is coplanar, same plane, with line JK and line KL? So I have to find those. JK is this line, and KL. And how do I know it's a line? Because it has those 2 arrows. It's not a ray, it's not a segment. It's got 2 arrows, it's telling me it's a line. Keeps going. JK, where's JK? Oh, I just did that one, KL. Oh, this, what is the name of a line that is coplanar in the same plane as this? Top. Yeah, do you see how the top is like a, yeah, so a line that is coplanar would be JM, like this one here, or ML is another one, or ML, there. What is the name of a line that is in the same plane as these 2 lines? So this whole lesson is really on learning new words and understanding what they mean and how to write it correctly. So if you are not so good with figures and numbers, this is your time to shine. So make sure you read this again and memorize, try to memorize the words that you learned and go over them again. And here on the homework, this is where you're going to practice those. So you got number 9, number 10, and it's, if you go down the line with our examples, they follow the same exact, how do I say, they go down the line just like that. You can find the example 1 will cover the first question. So you want to compare what we did earlier, okay? Number 12, 13. Now it's talking about rays. So I would draw it out. AB, ray AB, beginning point A, and here's beginning point B. And you can explain if it's yes or no, is it the same ray? Go back to that example. And then number 14 and number 15. And on this page 449 on the top, it's going to ask you about this shape, this figure right here, where two planes intersect. And let's read that. Postulate 4 states that any 3 non-collinear points lie in exactly one plane. Find the plane that contains the first 3 points listed. So you find, by the way, you're going to do 16 through 21. So you look for the first 3 points and what plane is it? Yeah, you identify the plane and then you have to decide whether the 4th point is in that same plane. Yeah, and then you have to, if it's yes, you write coplanar. If it's not, you write coplanar to describe that. So you look for this plane, ZSY, that's this plane right here. And then look for C down here and decide if it's the same plane, yes or no. And if it's yes, which it is, by the way, then you write coplanar. And if it's no, you write non-coplanar. It's a hard word. You're going to do all 6 of these. Okay. And then to make it final, you're going to draw things and see if it's possible to draw those things. If possible, draw a figure to fit each description. Otherwise, write not possible. So you're going to see if you can do these 4, if you can draw it or not. Can you draw 4 points that are all on the same line? I would say yes. Okay, so you need to draw it. Okay, and then so on and so forth. So that's it for this assignment. Hopefully it's fairly easy for you. I always enjoy geometry. I hope you do too. And I'll talk to you later.